everyone, welcome to my YouTube channel Code with Shash. So today is day 9 of Grind 75 challenge and I am solving flood fill. So I will move on to the question. This will be a slightly longer video because the topic is a bit complex. So the question number is 733 and it's named flood fill. And I will also tag which all companies it came to. You can check it out in the thumbnail also. So let's jump into the question. So basically I am given a image. They are saying it is an image, but it is basically a matrix of integers. As you can see here, it will be given like this, and I will be starting from a point in that matrix, and that is given by SR and SC. So they are saying like in each of the pixels of the image, that is in each of these boxes, we have an integer, and this integer they are referring to as color. So basically I have to go 4 directionally, that is up, down, right, left, not in the diagonal manner. We can't move like that. And I have to check if the color that was in my starting index matches in with any of the 4 colors up there. If it does match, you have to change it to a new color that is provided by this color value here. That is again also an integer. And yeah, this goes on. This will actually go on repeatingly. So from this one we will first go to this one, and this one change its color, and then from here we will also move to the other two, this one and this one. So this is keep on repeating. This is what will happen. And obviously there is an edge case. If the color is the same of the starting pixel, we do nothing, we just return the same image that was given to us. So this is that one. I have done the solution and I have done it using DFS, so which will bring the time complexity to O of n, and the space complexity will also be O of n. You can also solve it using BFS. It really doesn't matter here because the output that is our image, and in what order you are changing the color of each pixel, that really doesn't matter to the final state. So you can do with either of them, it shouldn't be an issue. So I will move on to the question, how I solved it and what was my thought process. So obviously seeing the second use case, I would obviously put this one and check if the starting position is the same. Then I don't do any computation, I just return whatever image was there. And let's jump back to the constraints once. So you can see the most important constraint here is m and n, which is less than 50. So these are fairly smaller numbers. We can maybe solve it in a lot less efficient way. That's why maybe it is tagged as easy here, but yeah, I have solved it in the efficient way. So let's stick to the solution now. I just wanted to touch upon the constraints because those are important for most of the questions. Next, I am just extracting some useful values that we might need. This is I have put this as MR and MC, but these are basically length of row, the total length of row, and the max length of column that can be. And I am also storing the color of the starting point in an actual variable. Then I am basically writing the code for DFS for an matrix or a 2D array, whatever you say. So these are the 4 directions that I can move in. I have quantified them like this, and this is what I am creating, a false matrix. So this will be basically keeping track if we have visited a element so far or not. So these are the 2 fundamental things I need to create, and this is from where the space complexity also comes from, line number 11. This is what causes an extra O of n space, right? So then comes more to my DFS, and the algorithm works in an recursive way. So what I am doing, I am changing the color as soon as I get in, and changing the color and then marking that index as seen. Then I am iterating over the direction array here on line number 10, and I am creating the new indices by new r and new c. Then I am checking it should be within bounds, that is it should be greater than 0 and less than my max for both of them, then I am checking if it is visited or not. If it is visited, obviously I won't visit it again. I don't want to reiterate and waste computation. And then the exclusive condition for this question, we have to add this condition specific to this question. This has nothing to do with how DFS works. So what we are doing, we're checking, right? If it doesn't match, then this condition doesn't fulfill. We don't move on to that index to change its color, right? So as you can see, 0 doesn't match with 1, so we don't move on there and change it to 2. So then yeah, we are recursively calling. Then if any of this satisfies, then we just skip this line number 20. If not, then we recursively call the DFS. As DFS works, then in the end I am just calling the DFS and returning the image, because I am changing the image in place. I am not passing any reference to the image then returning from the recursive function. So I can just return the image from here in the last line. So that was the solution. This question has been asked in Uber. I guess they just love the BFS, DFS questions and questions related to graphs. Okay. And if you have any questions regarding this, you can drop them in comments. And thank you for joining in. Have a great day.